Hello guys, this is Expert Honda and you're watching on YouTube. So let's see today question what we have in on Leetcode. That is we have 1402 1402 reducing the dishes, right? So let's read the question. So a chef has collected a data on satisfaction level of his end dishes, right? So a chef generally he used to cook the food in you can say in a hotel, and people get those food in the hotel, right? So question is saying that a chef has collected data on the satisfaction level of end dishes, and a chef can cook any dish of you can say one item at a time, right? So a chef can cook any dishes, right, in one unit of time, right? Let's understand. So like time coefficient of a dish is defined as the time taken to cook that dish in the including previous dishes multiplied by its satisfaction level, right? So what we have to do, we have to actually we have to take the time and we have to multiply with you can say satisfaction level, right? So you can get time from the time array, and you can get the satisfaction level also, right? Now what we will say that we will have return the maximum sum of you can say like time coefficient, right? And that the chef can obtain after the dishes preparation, right? So we have to return the maximum sum. What we have to do, we have to return the maximum sum of you can say dishes after preparing the dishes, right? Then dishes can be prepared in any order, right? And the chef can discard some dishes to get maximum values, right? So he can do that. Okay, so give me 1 second. Okay, so let's again read again, right? So it is saying that a chef has a collected data on the satisfaction level of his end dishes, and he can cook in one unit of time. And what we have to do, we have to return the maximum sum of you can say like time coefficient that chef can take after preparation of the dishes, right? That we have to do. But question is saying that dishes can prepare in any order, and chef can discard some of the dishes to get maximum values, right? That we have to see. And one of the this one is you can say time coefficient of this is defined as time taken you can say to cook that dish, and into we have to multiply with the satisfaction level, right? So that is called time you can say like time coefficient, right? Now what we will see, we have example that is called satisfaction, right? So it has the input of satisfaction as you can see, and we are getting some value, right? So what we will do, we will re-represent this one into an array. So how it look like, right? So the satisfaction we have given is -1 we have given, then -8 we have given, then 0 we have given, 5 we have given, and -9 we have given. Okay, so if I'll represent this one into array, it will look like this one, correct? Like this one. Now what I have to do, after removing the second, right? After removing the second and last dishes, right? So second dishes is this one and this one, correct? The maximum total like time coefficient will be equal to, we have to multiply this one, right? Like this. So 1 into -1, 0 into 2, 5 into 3, and 4, it will become what? 14. How? See, time at time at I what we have here, what time we have got? We have got you can say -1, right? So -1 into 1, here time we have taken, satisfaction level is 1. Let's suppose satisfaction level is 1. So I'll start with 1 2 we should okay, after removing this, right, we have to take 2 3, and this is removed, right? Let's suppose this is removed. So what we will do, we'll multiply with this one. So 1 into 1 is become this one, 0 into 2 it become 0 into 2, and 5 into 3 it become 14, right? So that is the reason this is happening. Okay, so first we will remove this line and this one and this entry, because see, so after removing the second and the last disease, right, so total maximum total like time coefficient will be equal to this one, right? We have to multiply this is each values, right? We have to multiply 1 into this one, 0 into 2, and 5 into 3, right? And then we will do the sum, right? And this sum will become 14, right? So each dish is prepared in 1 unit of time, right? And so because see, it is taking 1 time and 1 time here, right? 1 second taken here, let's suppose 1 second here, 1 second is here. Now it will become 2 seconds, right, here, because 1 second is here, 1 second he is taken here, right? So if you'll do the count, right, it will become what, 2, right? We'll do plus 1 here, so it will become what, 3. Like this it is increasing, right? It will become 4, right? But we should not start with 0, right? Here we'll start with 1, right? And that's why it is happening here. Okay, now let's understand another one that we have is 4, 3 and 2, right? So similarly what I'll do, we'll start with 1, 2 and 3, correct? So what we'll do, we'll do 1 into 1 into okay, so first disease is 2, so it is starting, actually he is starting with 2, so 2 in 1 into 2 will take, then we'll take 3 into 2, and then we'll take 3 into 4, like so it will become 20. So these are the you can say satisfaction and satisfaction of I we have to take each time, right? I think you got it right. Yeah. So that's all. Let's understand. See, it is saying why we are taking like this. Actually we are taking any order, right? Dishes can be prepared in any order and can be discarded in any other order, right? That's why it is happening, all these things, right? I think you got it. Okay, so let's begin and understand another example. So another example we have is 3, and the satisfaction level is -1, -4 and -5, right? So people don't like this one. Actually we don't have in the positive, right? So all the dishes are waste, right? We don't need to do anything because all are minus in the minus, right? So the score will come minus only, right? And that's why satisfaction output is getting 0. So satisfaction level is if we'll do the length, so it should be equal to n, right? And n should be greater than equal to 1 and 500. So satisfaction of I should be greater than -1000 and less than equal to 1000. So this question has been asked in multiple times in Apple and Uber. So if we'll talk about the approaches, right, let's suppose if we'll talk about the approaches, right, so there is multiple approaches, right? You can see, and these 3 approaches will take you the time complexity, because we are using DP, right? So it will take time complexity of O and square, right? And space complexity will take same O of n square. Why? Because see, if n is the, if we'll take n is a number of dishes, right? Okay, so we will go with all the dishes, right? All the dishes we have to check possible state of all the dishes, and that will is nothing but what, all the possible states will become n square, right? So if we'll talk about these DP things, right, so it will take time complexity of n square, right? So we'll take we'll understand about one of these, right? Let's suppose I'll start with top down approach, right? And you can follow up any other 3, right, here, and if you want this video I can put there. So I'll start with this one, top down approach, and then I'll go with the DP sorry, greedy approach. So in the greedy approach it will become see, Greedy approach very important, because when we require time complexity should be more optimized, right? So in that case we should use greedy approach, and it will be take O of n, n log n, you can say, right? That we will see. This is your time complexity, and space complexity will take O log n. Okay, why it will take? Because see, the number of dishes we have given, right? And first we'll do some sorting, right? And then after we'll do here the work, right? So we'll see that, don't worry. So let's continue understanding top-down approach of DP. So we'll go to the code section, and then we will do the implementation. So if we'll talk about the approach, right, the DP, right? So we have given how many dishes? We have given n dishes, right? And each one of them can be obtained through what? 1 unit of time, right? 1 unit of time, and can be cooked in any order, right? So we'll take any order, right? And all dishes have you can say integer attribute that is called in satisfaction, right? So we have satisfaction array, and it will contain what? An integer attribute, correct? So we have defined a value for each dishes, so there will be some value, right? So if we'll talk about like time coefficient, right? So there is some value will come from here, right? So as the multiplication of its satisfaction come, right? So there will be some you can say this one, the time and the satisfaction, right? Satisfaction, like like it is given time of I, and then we have to multiply what? The satisfaction, right? Satisfaction at I, that we have to multiply, correct? So that will come our LCT, you can say, that will come our LCT, correct? So as the multiplication of its satisfaction value will become, so time taken to cook the dish including the time for the previous dishes, right? So we need to find the maximum sum of this value, right? What we have to do, we'll find our maximum sum, right? We have to find maximum sum, and of all these value, right? Like time coefficient. So what we have to, we have to consider that any number of dishes can be discarded, and the remaining can be cooked in any order. So any order will take and can be discarded also, you can say, plus we can discard any of the order, right? So we should note of we should take note of, you can say, characteristics of this problem at this time. So first we iterate over the dishes, and we must decide which dish to cook, and the optimal choices will depend on how many dishes we have cooked before the current dish, right? And as we have to include the time for those as well. So in order to, you can say, you can also say that each decision we make is affected by the previous decision that we have made. So otherwise we can say problem is also asking to maximize the sum of, you can say, coefficient, you can say, for each dishes, right? So these two characteristics suggest that we could solve this problem using dynamic programming, and we will discuss these approaches using dynamic programming, you can say, and then we will discuss on greedy approach, right? That we will say. Okay, so we should consider this example, right? And then we will continue doing that. Okay, so let me clean here. Okay, so let's suppose what we have to do, we'll start with the, you can say, top-down approach. Okay, so we'll start with the first dish, let's suppose we have, and then the options here, let's suppose we'll take we can cook, first dish will cook and we'll add into the satisfaction, and then we will multiply by 1, correct? So after this one, like, let's suppose we'll move to the next dishes, right? That will take 1 unit of the dish first, right? That we have seen, and then previous one, right? Similarly we'll move the next level, right? So now how we'll implement this one? Let's suppose initially we have taken 0 and 1, suppose. Next time either next we will move to 1 and 2. There is a next cook, and this time we are escaping, right? We may escape, right? What 1 1 we can skip, right? Next we will cook or we can escape. When we will cook or we will escape, like this we will go, and we will do some memorization of the all the ready calculated things, and we'll store somewhere. Let's suppose we have already calculated this one, because this part is already calculated, right? So if 1 2 is coming here already, right? So this part will store onto the you can say deep. We have already stored this calculation, so we will not do this one. That's why it is saying that it is dp, right? I think you already aware with the dp, right? If not, don't worry. Let's continue understanding the code into the code browser. We should sort this value, right? The satisfaction can be sorted, because if you'll sort this, then it's better to sort this one, right? So first of all, we'll do arrays dot sort is a function, right? Yeah, it will take the array, correct, and it will do sorting. Now our satisfaction order is sorted. Now what we will do, we'll take a memory, right? Memory, and it will store in 2D way, right? And let's suppose I'll give this as an integer. So this memory matrix will store our satisfaction, right? So we'll give the you can say the length will be satisfaction dot we can find the length, and we'll do +1. We'll take one more size, right? So let's go to do like this. Okay, so now it is done. Now what we have to do, we will mark all the state as -1, denoting that we have not visited it, we have not calculated yet, right? You can say. So to do that, what we will do, we will fill this array, right? So for we'll start with index I equal to 0, and then we will move to I should be less than you can say we have satisfaction, right? Sorry, satisfaction dot length, I'll take this one. Okay, satisfaction dot length will do, and we'll do I plus. Now we will move to all its row. So what we will do, we'll do to arrays dot we'll do fill, and we'll pass memory of I. What we have memory at I is we have to fill with -1, the initial value, right? So actually we are assign -1, right? And assign -1 and -1 for not calculated yet. Okay, after this what we should do, actually we will return our we can say maximum satisfaction, right? So what we'll do, we will do return get you can say maximum you can say satisfaction, right? Satisfaction, and this will take what? It will take satisfaction, and another it will take what? Memory that we are taking, our memory, and another will take what? 0 and 1. So we'll start with 0 and 1, because this is our index and time, right? 0 is you can say index, and 1 is its time. Okay, now we will create the function, because function is returning integer type. So I'll take this, will take integer, and we'll exactly take this one here. Okay, now first we have taken satisfaction, right? So satisfaction we already knows about it, so we'll take as it is here, and we know about the memory, that is 2D matrix. So I'll put here. Now 0 is nothing but our int index and int time. Okay, gotcha route, what we will do, we'll check the index size, right? So first of all we should check index. If index is equal to the last index satisfaction last length, means we have to return 0. We are not going to do anything because we are exceeding the length, exceeding boundaries, you can say. Now what we'll do, we'll check if we have already calculated the answer. So we need to go to into recursion, right? So first what we'll do, we'll check if memory have, and memory contains what, this index, and another is what, time, correct? If this value is not equal to default value -1 that we have filled, then it means it's already calculated, means it's already, if already calculated, if already calculated, right? Then what we will do, we'll return what, if we have already calculated, right? Then what we will do, you can say we'll return from the memory index and time. Okay, after this what we should do, first we should what we have to do, actually we have to return the maximum of the choices, right, that we have. Either we will cook or either we will skip, right? So two choices we have, we will cook. Then if we will cook the dish, right, at certain index, right, then what will happen, the time that we take will move, right, to the next level, right? So we will move on to the next dish with time, we'll do time +1, right? And if we will skip the current dish, right, then we will move to the next dish at the same time, right? Means we have to return, actually we'll say at memory, at you can say some index is there and some time will be there, right? So at here we'll do what, math dot will do max, and this will take you can say satisfaction, right? So I'll take satisfaction of some value that is nothing but our index, and we'll do multiply by its time, correct? First we'll take this one. Another, what we'll do, we have this function already, right? Get method, right? So this get satisfactory method, we call this one at this certain value, and we'll do what, we'll do plus, actually we will calculate the satisfaction plus, we'll do previous you can say if some value we have already next level, right? So this will come index and +1, we will do +1, and here it will take what, time, and we'll do time +1, that for the next, either we'll skip or not. So here we are not skipping, actually this part we are not skipping. Okay, so I'll take this one, let me check what I'll take, int cook. Okay, if we'll do cook, then we'll take this one, we'll take int you can say skip, then we'll take like this. Okay, so just we'll update these values, right? And so first we have satisfaction into time, what we have, satisfaction into time, and we'll do plus, we'll call the get maximum satisfaction at the satisfaction memory we have, just we will update our index +1 and time +1. Similarly we'll have our we have satisfaction, just we'll check if we are skipping. If we are skipping, we'll do index +1, but time will remain at the same. Okay, and if we have to take the choice, so this will come here a choice, right? So how we'll get the choice? So if this is our choice, let's suppose this is our choice, so we'll do int choice is this, and either we'll take what will cook or either we'll do skip. Got it? I think you have understand, right? Either we'll cook or skip, right? What you want to do, right? So cook 1, this is our cook 1 and this is our cook 2, you can say. In which one we have to choose, right? This is our choice, right? So 2 choices we have, in which we have to take the maximum one, right? And I think this will work. Let's okay, what is happening, let me check. Okay, we'll start from here. First we'll do this sorting, then we will fill up its -1 as a value. After this, what we'll do, we'll coming to the satisfaction, right? Get satisfaction. We'll take satisfaction, memory and index and time. After this, if satisfaction at the exceeding boundary will return, if we have already calculated will return, right? If we have to skip, right, the first will come index into time, then we will do plus what this one, right? Okay, here we have already did this one, right, into plus, right? So we don't need to do this one. Actually we will just pass skip level. In skip we don't have to do we will add, right, at the same time. What we have at the same time, that we will return actually. So let me write here so that you will understand. So actually while skipping the current disk, right, what we have to, we will move to the next disk, right? Skip and move to next, or you can say disk, next disk at same time, at the same time. Okay, at the same time. And here when we are choosing the cook, right, so what we will do, we'll cook at the some index, right, with certain time, right? We'll have some time, right? And so we can say cook and move time with index increment means cook and move with time increment and index increment, time increment and index increment, right? You can say cook and move. We already know this will cook, and here skip and move will say move to the next disk. Okay, I think you got it. Let me run this one. Yeah, let's submit this one. This is working fine for me. Okay, so if you like this video, please hit subscribe so that you will get more videos like this. Okay, so what I'll do, first of all, I'll say that time complexity will take you can say O of you can say n square, right, n square, and space complexity will also is this one. Okay.